Hello students, we have completed all the theory and the concepts in the chapter. Now it is time to sit down and work out some problems. First, a quick recap of all the concepts. You can see scarcity here, opportunity cost here, PPF, CBA, utility and marginal utility. Make sure you're familiar with all these concepts before you proceed to the questions. Let's move on to the questions now. Now, the first 4 questions are very similar in nature. The first question is, a consumer wants to consume 2 goods. The price of the 2 goods are rupees 4 and rupees 5 respectively, and the consumer's income is rupees 20. Write down the equation of the budget line. How much of good 1 can consumer consume if she spends her entire income on that good, and how much of good 2 can she consume if she spends her entire income on that good? And final part of the question is, what is the slope of the budget line? So let's answer these questions now. First thing, X1 is good 1, X2 is good 2. Let's make these assumptions. P1 is the price of good 1, P2 is the price of good 2. So P1 is given as 4, P2 is given as 5, and the income or Y is given as 20. Now how do we write the budget line equation? Y equals P1x1 plus P2x2. So substituting, we can say 20 equals 4x1 plus 5x2, and that is the answer to the first part of the question. This is the budget line equation. Now, if only good 1 is being purchased, which means good 2 or x2 becomes 0, right? Then our equation becomes 20 equals 4x1, which means x1 equal to 20 by 4 equal to 5. So 5 is the final amount of goods that can be consumed or purchased if only good 1 is being consumed. Now what if only good 2 is being purchased with the entire income? X1 becomes 0, so 20 becomes equal to 5x2 now. So x2 is equal to 20 by 5, which is equal to 4. So 4 is the number of units of good 2 that can be purchased with the entire income if only good 2 is being purchased. Now finally, what is the slope of the budget line? Slope of the budget line is defined as the ratio of the prices, so minus P1 by P2 or minus 4 by 5, which is equal to minus 0.8. Now the next 3 questions are related to the first question with some tweaks. So second question is that, how does the budget line change if the consumer's income increases to rupees 40 but the prices remain unchanged? So our P1, P2 remains the same, only our Y changes. So let's just change the equation now. What do we get? We just get 40 equals 4x1 plus 5x2, which is our new budget line equation. Now how would the budget line look like? Let's plot it and see once. Now this is what the budget line would look like. And how did we get this? We just plot these points 4 and 5, which are the 2 intercepts we get by just finding out how much of each good will be purchased if only that good was being purchased. So we already got the 5 and 4 points. We join them together and we get the budget line equation. Now how would the budget line of this look like in a graph? It would just be that the budget line, original budget line, shifts outwards like this, right? So this is the new budget line. 40 equals 4x1 plus 5x2 is the new budget line. Let's go to the next question now. How does the budget line change if the price of good 2 decreases by 1 rupee and the price of good 1 and consumer's income remain unchanged? So only P2 is changing. So earlier P1 was 4, P2 was 5, now P1 is 4, P2 is also 4. So substituting, we just get the new equation as 20 equals 4x1 plus 4x2. That is the new equation. And how do we see this graphically? It would look like this. All that has happened is that because this good has become cheaper, more of it can be purchased. So the budget line has swiveled outwards like this. And we get the new budget line at 20 equals 4x1 plus 4x2. So the intercept here has changed because more can be purchased there. So that's it about these questions. Now one final question in the set. What happens to a budget set if both the prices as well as the income double? So before we go to the budget set, first let's see the budget line and how that changes. The original budget line is 20 equals 4x1 plus 5x2. Then we get the new budget line by doubling everything, which is 40 equals 8x1 plus 10x2. Now we can just cancel those out. So we get 20 equals 4x1 plus 5x2 again, which is the same budget equation as the earlier one. So budget line has not changed, budget equation has not changed. And the budget set is derived from the budget line or the budget equation by just seeing for each price how much goods are consumed. So the budget set also does not change. So that is the answer. The budget set does not change in this situation. Now let's go on to the next question. Suppose the consumer can afford to buy 6 units of good 1 and 8 units of good 2 if she spends her entire income. The prices of the goods are rupees 6 and rupees 8 respectively. How much is the consumer's income? So we can write good 1 is X, good 2 is Y, price of X is PX, price of Y is PY, and income is M. If we denote like this, the budget line is nothing but PXX plus PYY is equal to M. And if we substitute Px and X and Py and Y into the equation, we get 6 into 6 plus 8 into 8 is equal to M, and we straightforward get the answer M is equal to 100. The consumer's income in this case has to be equal to 100. Let's move on to the next question now. Suppose a consumer wants to consume 2 goods which are available only in integer units. The 2 goods are equally priced at rupees 10 and the consumer's income is rupees 40. Write down all the bundles available to consumer, and among those bundles identify those which cost her exactly rupees 40. So there are 2 things given in this question here. Price of goods are equal at rupees 10. Both the goods are priced at rupees 10 and income is 40. So that is the upper limit. We cannot spend more than 40 rupees. Now based on this, let's see what options are there, right? The first set of options we can create by just keeping good 1 constant and just varying good 2 and seeing what all combinations are possible, right? So let's take 0, 0, good 1 is at 0, then 0, 1, good 2 has become 1, good 2 has become 2, 0, 2, good 2 becomes 3, 0, 3, good 2 becomes 4, 0, 4. All these are still possible. They're all below the budget line, right? If budget line is here, all those points are below the budget line. But 0, 4 becomes on the budget line somewhere. Beyond that, 0.5 is not possible because 50 rupees has to be spent and the income is only 40 rupees. So that much cannot be spent. So these are all the options possible if good 1 is fixed at 0. Now if we fix good 1 at 1, what combos are possible? 1, 0, 1, 1, 1, 2 still possible, 30 rupees. 1, 3, it has become 40 rupees now. We hit the budget line. Further is not possible. 1, 5 is not possible. So that becomes a set. Then we increase good 1 to 2. Then what happens? 2, 0 is possible, 2, 1 is possible, 2, 2 is possible. And now let's increase good 1 to 3. 3, 0 is possible, 3, 1 is possible, 3, 2 won't be possible, right? Then finally, let's increase good 1 to 4, in which case no money is left for good 2 anymore, so that becomes 0. So 4, 0. Can we increase good 1 any further? Not possible. So this becomes a final one. So this is the answer to the first part of the question. These are all the possible outcomes, all the possible combinations. Now if we go to the second part, it is which of these combinations or which of these bundles allow us to spend exactly rupees 40. So just take the final one of each of them. 0, 4 is 40, 1, 3 is 40, 2, 2 is 40, 3, 1 is 40, 4, 0 is 40. And we write them out like this, and this is the answer to the second part of the question. Now the next few questions are all about monotonicity of preferences. Now monotonicity only means that given 2 bundles, a consumer will always choose the bundle in which at least one of the goods is more in relation to the other bundle. That is a simple concept of monotonicity of preferences. Now based on this, let's try to answer these questions. If a consumer has monotonic preferences, can she be indifferent between the bundles 10, 8 and 8, 6? 10, 8 and 8, 6. 10 is more than 8, 8 is more than 6. So she cannot be indifferent between these 2 bundles. She will be preferring 10, 8 over 8, 6. Correct? Let's go to the next question now. Suppose the consumer's preferences are monotonic. What can you say about her preference ranking over the bundles 10, 10, 10, 9 and 8, 9, 9? Now obviously 10, 10 with the maximum of both goods will be rank 1. 9, 9 with the minimum of both goods will be the final rank 3. And 10, 9 which is having one more good over compared to the last rank bundle will be at rank 2. So this is the final ranking. Next question is that suppose your friend is indifferent to the bundles 5, 6 and 6, 6. Are the preferences of your friend monotonic? Now let's examine the 2 bundles. 6, 6 is here, 5, 6 is here. 6, 6 is having more of at least 1 unit of the goods compared to 5, 6 bundle. So according to monotonicity, 6, 6 should be preferred over 5, 6. So no, the preferences of your friend are not monotonic in this case. With that, we come to the conclusion of this chapter, including the practice questions. Make sure that you go through these questions yourself and try to solve them as well. Thank you.